Okay, so I think we can start. Thank you all for attending this session. The intention of this session is to give you a little bit of an insight into a very interesting program that University of California, San Diego, the Department for Extended Studies, is giving in partnership with NIT Academy, and to try to answer along the way some of the typical questions related to safety and functional safety in more detail about our so much anticipated self-driving vehicles, self-driving cars, especially passenger vehicles, and to see what is out there that we need to be aware about and what is out there that we can solve it, what we could do to design a promising safe self-driving car. There were a lot of different attempts. Some were less successful, some were a little bit more successful, but still we don't have a massive rollout, and this is definitely an opportunity for many people in coming years, so to say. I have with my name is Milan Bjelica. Let me introduce myself first. I'm a functional safety instructor with the University of California, San Diego, and I'm also CEO of NIT Academy, this being the most prominent program of NIT Academy and one of the programs that we focus most of our attention to. Together with me is my colleague, Professor Bogdan Pavkovic. He is also with the University of California, San Diego in this capacity, and also one of the instructors on the functional safety topics. Welcome, Bogdan. Can you hear me?
Yes. Hi everyone.
Unfortunately, I cannot hear you.
So I
must check what's going on.
Can you hear me now? It seems that microphone is speaking. We can hear.
Can everybody else hear Bogdan, maybe?
Yeah. I can hear Bogdan.
Yeah, I think Milan, you're the only one.
Okay. Anyhow, we could start, Bogdan, if you can hear me, and maybe, although I cannot hear you for some reason. Something is okay. Let me check like this. Maybe I can hear you now. Okay. Let's start to give you just an overall introduction in the functional safety engineering for automotive. What does this actually mean? And to try to answer the question, are we finally going massively autonomous? So this is the question. So we do have some robotaxi services here and there, and we do have a lot of great demonstrations, but the massive rollout is still under heavy brakes. Even in the US, that is a very prominent field, a very prominent area, so to say, for the deployment of new tech that is, let's say, much faster paced, etc. Europe is more conservative traditionally, and also in this regard, we are waiting for approvals in a lot of countries for self-driving vehicles that have hands-off capabilities for drivers, meaning that we could be driving a car without necessarily paying attention to the road at all times. What is the problem in this implementation? Of course, it's a complexity of the world around us. As you can see in this figure, although we could intuitively say, okay, we have some pedestrians, we have some horizontal signalization, we have traffic rules, etc. It looks like a chess playing game, but when you start digging deeper, you figure out that you have the same level of complexity as anywhere in the world. Basically, the world has many shades of different colors, and it's extremely complex to grasp all the details and all the fine-grained things that are out there. And there are a lot of edge case situations that simply cannot be dealt with easily. And this complexity is what makes it really, really hard to create a fully self-driving vehicle in all scenarios that can be massively deployed and that we can all ride in, basically, once we get it from the store. Okay, so why the legislators are not so keen to adopting the technologies that are rolled out and that are demonstrated. They need to see some solid proof. One of the ways how to prove the safety and what is being used by so-called disrupting companies that are now in the US, for example, is the safety case through real-world testing. So you probably heard about Waymo, of course, but different others, Cruise and different other companies that have different test fleets that are used all around the country. But these fleets are not that big. We are talking about a couple of hundred of vehicles at most. And of course, those vehicles are gathering data. They have some safety drivers on board, but usually they drive autonomously in some regions, and they gather data. And this way of proving safety by showing that you didn't have any accidents or incidents is one of the ways that companies are trying to make their case in front of the legislators. However, since the infamous RAND study in 2016 and also a lot of works in recent years, some of them were authored also by my team, we figured out that you would need to drive billions and billions of miles to be able to provide a statistically significant proof of safety by showing the results of actual driving. So it's intangible and it's almost unattainable by most of the companies. So definitely this way alone would make it probably enough for some limited areas or for some limited use cases that can really serve as a playground, some streets, etc. If you really want to have a massive rollout, this is a very, very hard way to go. And we'll wait for maybe even decades for these proofs to be completed. The other way is going for a safety case by the book, so to say. It's by following strict development processes and procedures as prescribed by the safety standards that exist out there and that we are going to also talk about in this webinar. This is traditional approach that was followed, of course, by the aerospace industry, by the rail industry for decades, but also from the automotive industry standpoint, especially here, even for the autonomous driving, they are using this approach in Europe. However, for this way to be actually operational and to yield real results, we need a lot of time and a lot of investments. It takes a tremendous amount of work and the transformation of companies that are traditionally software driven, because we know that you need software for self-driving cars, you need AI, you need complex computers, all those things that we have in the consumer electronics world, but actually in the automotive were not so frequently seen. Those controllers in cars used to be a lot smaller and a lot less complex, and now with this amount of complexity and the software, millions of lines of code there, this safety case by the book is no longer such an easy ride. Actually, it proves to be very hard, if not impossible to attain. There is one modern approach that is on the intersection of those two approaches, and basically we also tap into modern standard developments and what is going in which direction in the research sense. This is why we believe that the safety case and the learning about safety is best dealt with when you combine real-world industry experiences that were proven to be correct, and also combining some research-driven agendas together with the standardization bodies and new modern standards. This program, Functional Safety Engineering for Automotive specifically, by NIT Academy and UCSD Extended Studies, is, I can say, among the first, if not the first in the world in this kind of detail, that should serve as a turnkey solution for safety projects in automotive. So if anyone would like to really dive into this field, then this program should be one and only you'd ever need to take to be able to get both lectures and the consultancy behind that to be able to really work in these fields and be able to deliver things that would in the end be candidates for this massive rollout of autonomous vehicles. I would ask Bogdan maybe to share a few thoughts on this general story before we dive into the program details itself.
Yeah, definitely a nice introduction, and I would just like to continue further in this vein. We are seeing these tremendous changes in autonomous driving, where software is the driving factor, and some people might say that traditional standards for functional safety do not suffice, and this is not completely false. But I would say that without these standards, or these standards can be seen as a basis and foundation upon which we are building further, and thus we are seeing further standards which are trying to further provide guidance how to actually demonstrate that our self-driving autonomous car is safe enough. So we're seeing standards like SOTIF, but also standards in US, which are guiding us through the process how to provide a compelling and convincing safety case. So one is UL 6400, which is giving us step-by-step guidance how to further tailor and how further detail the safety case in order to achieve the wanted goal, basically to demonstrate that our self-driving car is sufficiently safe and that we can roll it out in masses on the streets. So what we tried with our program is to give you foundation and really to dig deep and to really address all the necessary prerequisites in order to dive into this exciting and challenging field. And then upon on this basis, we have also other programs that are building on top of this. So this fundamentals program that we are offering, and we'll talk more about the details in upcoming slides, is a basis layer, like a foundation of the house. And on top of it, we want to address some more novel concepts that will go into the direction of self-driving cars.
Mm-hmm. Thanks a lot. I agree perfectly, of course, with what you said and what are the dominating forces, the software as such. But I would now, when opening this syllabus, to share one information that I also got from experience from the previous two groups that went through this program. So this would be a third round of this program, the third year. So we already have a lot of people with these certificates. However, there are also different other flavors of these trainings happening, of course, longer than the last 2 years. It is one of the most prominent problems is the complete unawareness of safety and even of system engineering from mass audiences, mass engineering audiences that embark into the development for autonomous vehicles. So unfortunately, computer engineering programs and software programs that are taught in the universities are crafted in a way that are tailored more towards the paradigms of, you know, traditional Linux, Unix way of thinking, where we have open source, where we have debugging concepts, where we have alphas, betas, you know, like software reliability that is actually a curve flattening, meaning that you lose bugs while you are testing the software, or even while you're using the software. This approach is fundamentally troublesome with regard to designing for safety. It's not completely wrong, but it makes our mindset a bit difficult to change when we start thinking about safety. So this is why we crafted this program with a course called Systems, Functions, and Safety. This is a roof course, and our way of teaching is hierarchical. So basically, you can take only this course and that to be it, so not to take any further courses. You would get enough information to understand the field, so this is very important. It would give you all the details about the system engineering, requirements engineering from the standpoint that is applicable, using hands-on exercises, of course, what is one of the traits of the complete program, and we are going to speak about that more in the future, now only like a topical view. Then to understand what does it mean to delineate the system, to understand the system, together to elicit requirements as a key problem, let's say in the V model design, and also to try to understand which functions the systems have and how those functions might fail, to analyze the safety of the system, and then to prescribe measures which are required to achieve safety, and in the end, how to prove all that through calculation. So it's not just a random thing, you know, you might think this could go wrong and then you do something randomly about it. You should be able to probabilistically express that, to put that into calculation, to use appropriate tools for the purpose, and to close your safety case. So this complete field is covered in this first course, of course not in that level of depth, but in the level that is enough for the overall comprehension. This being said, the course on fault-tolerant systems would deal in much more depth about the design of fault-tolerant structures. Now, when you know what is the actual reliability of your system and how your system is safe, you need to know what to do about it. So which are the techniques on physical level, on informational level, on software level, on temporal level, to try to address these problems and to try to increase the safety integrity of the system, how it's called. So through these different fault-tolerant designs, you probably heard randomly in many talks about redundancy and diversity. Here, redundancy and diversity are going to be explored in technical details and also in mathematical details, in the sense how you actually show that a dual redundant structure would be reliable and the single instance structure would not be reliable. So this is something that is taught in this fault-tolerant systems course, and there's a lot of hands-on examples from the automotive world. Just before I hand it over to Bogdan to explain some additional courses, I must say that this syllabus is a UCSD way for you to get a certificate. It doesn't mean that you necessarily need to take all those courses. So you can take the first course in any case. I would say it's useful if you haven't been into safety before, into safety for automotive definitely. But apart from maybe obliging you to take this first one, all others are more or less optional depending on what you need to have and to achieve. Of course, we recommend taking all 5 to be complete. But if you, let's say, want to you feel like you understand the process and quality framework, you probably can skip a course or 2, or if you know to do FMEAs, maybe you don't need to do safety analysis techniques, whatever. So whatever makes you happy is a possible route. It just this is our feeling. What is the let's say enough and very complete for the functional safety in automotive? So when you go through these 5, you're done, basically. Okay, Bogdan would maybe disagree and say, okay, there's a lot more to that, but we can speak about that a bit later. Maybe I can show you, Bogdan, this next slide where you have some props on these 5 courses. Maybe people can also read through to remind themselves, maybe to take a screenshot or something of these.
Yes, so as you said, I agree that I would say the first course on systems, functions, and safety is a must. So it's a basis, and taking other courses without listening to this course would be like skipping some necessary steps. I mean, it might make sense in some cases where people are already familiar, but a fresh start and a fresh alignment with our methodology is also a good point why to take this course. The rest of the courses were selected in such a fashion to cover complementary aspects of functional safety, and step by step you will be progressively learning about different aspects. So after learning the generic terms, generic techniques, you can learn about how to make the systems fault tolerant through redundancy, but also through other mechanisms and design aspects. And then once you know how to design the system, you can analyze them through the application of safety analysis techniques. And we'll cover many techniques. Some of them are listed here, like HAZOP, FMEA, FMADA, FTA, ETA, VISMA, etc. And this course gives you a way, practical way, to learn how to actually estimate how safe your system is, what are the underlying causes that are producing hazardous situation and accidents, and also to give you feedback what are the pain points and what are weaknesses in your current design and how to approach them and to close them. Then once you have covered these 3 courses, you have a good basis to dig deep into the basis of all the automotive development, which is ASPICE. So this is this fourth course where you will learn what are the process level step-by-step that are needed in order to put this in practice. So, and this is kind of forgotten from the engineering perspective, but if you want to go into this domain, this is a must. And finally,
you cannot qualify for developing in automotive arena without it. So it's important to say. So this is all the rest is about know-how, and of course it qualifies you as an expert, but this is the actual requirement. So you need to have this audited in the end, yeah? Or then
yes. So and this is why we are completing this program with the 5th course, which is kind of rounding up all the aspects, trying to cover the basis with terminology, align it with terminology of the automotive standard ISO 26262, and then applying the appropriate selection of the safety analysis techniques, applying the design principles from the fault tolerance system, and following the processes which are basis from the quality domain, but also transferring and moving forward to the safety domain. In this course, the focus is on functional safety and functional safety standard ISO 26262, but also we explore other relevant safety standards like SOTIF, which is an emerging standard which aims to cover autonomous driving specifically. But we also cover other standards just to give you a relation to other technological domains like industrial machinery or some medical devices. And the idea of this 5th course in this fundamentals program is to round up all the knowledges, follow the same methodology, and to really give you a chance to put everything in practice. Whatever you have started practicing in the previous courses, to have it really end-to-end example from the automotive domain.
Basically, this program, these 5 courses, is something that is at the core of functional safety fundamentals for automotive. We will speak in this session about the schedule and about the means, how we actually teach. So stay tuned for that. It will come. And then after maybe 10 or 15 more minutes, we are going to open a Q&A. I see some people writing in the chat. Let's see whether it... Yeah, this is just our link. Okay, so it's still no questions, but feel free to drop any question in the chat. So we will address those questions after we finish what we believe you would ask anyhow. So we'll just talk it through without you even asking. Okay, so Bogdan, maybe you can share a few words on additional courses that people can take, maybe not that deep for the sake of time, but there are, of course, some deeper dives for those who want really to extend the knowledge in these areas, or maybe that are already functional safety engineers that want just to drill down into the software part, or maybe into the testing part, or some other parts.
Sure. Yeah. So after completing a roundup of this first program, which is titled Fundamentals, this is meant as a more advanced follow-up, entitled as a Functional Safety Engineering for Automotive. It consists of 4 courses. The idea behind this program is to really give people who have either completed the first fundamentals program to really dig deep into the topical challenges around these 4 topics. So first 3 ones are practical ones, and the 4th one is again a way to provide an umbrella to address all of the previous aspects. So what we have on the menu this time, so is automotive functional safety design, which we think is a kind of understated or overlooked aspect of systems engineering, requirements engineering, and proper design using the both safety analysis techniques, but also design principles for safety. So this is a way to, in a vertical fashion, to drill deep and what you have started in the 5th course in the previous program to really develop further and to move forward towards a more realistic functional safety design. Same goes for the next one, functional safety software. We not only teach you about the principles, about theory, but also give you opportunity in each of these courses to have 2 practical projects where you have a dedicated time to really dedicate time and efforts to properly design functional safety softwares using all the lessons learned from the theoretical part. And finally, neither of these systems that is meant for functional safety arena is kind of incomplete, and it's not following the exit part of the V model. So thus we need a safety verification and validation, meaning that what we have designed and implemented needs to be scrutinized according to the testing plan, and then verification and validation plans when we move further in the integration steps. So from the software hardware to system, and then finally vehicle level. And finally, this automotive functional safety capstone project is a final opportunity to go really into direction to really emulate a real world scenario engagement on a real functional safety project in order to deliver something that could be properly assessed.
Okay, those are definitely great points to consider, and we do have additional automotive engineering covered. I know that it is not all about safety and the functional safety. A lot of effort shall be like hard labor in the context of automotive software frameworks, in the context of communication interfaces, in context of actual automotive tools, testing of the ECUs with actual equipment used for that in the automotive world, but also to drill deeper around sensor fusion, image processing, autonomous driving, AI stuff. But last but not the least, the very programming skills. In the automotive, we have the situation that everything starts teaming with C++, the modern dialects of C++, at least 14, if not 17 and 19. Also, of course, C is unavoidable there for the safety controllers, definitely. Also, the context of actual automotive environment is there. So these courses are given either through UCSD extension or through the NIT Academy. So we will not spend that much time talking about them, but those exist in the offer to complement. Bogdan, did you want to add?
Yes. Yeah, so just one final remark here. So if the programs around functional safety gives you a broad base and a structure and a framework, these courses that we mentioned here will give you like in-depth technical knowledge to really pursue this implementation, especially of diverse aspects.
Yeah, and although those default, so to say, courses in functional safety do give you broad view, those are still heavily loaded with exercises. Those are technical style exercises, tabletop exercises, designs, architectures, and everything. So even software, depending on which courses we are talking about. So yeah, so these are not purely theoretical. We don't even do like that. So it's not how we do this.
Yes, maybe,
yeah,
maybe now is the moment to address. We have a question in the chat. So how much hands-on work is included in this educational path? Is this all done on some real examples from the field? Yes, I guess here we will talk a bit more about the methodology, but definitely answer is yes. Examples that we use for teaching are based on real examples from industry, because all of us have, let's say, a crossover from industry to academia, and we are sourcing all the examples from realistic use cases, from real projects, of course, respecting the NDAs and respecting the authorship, but general ideas and examples are as close as they can get to the real world scenarios.
Yeah, so our goal when creating this program was to actually relieve the pain that we went ourselves in the industry projects when we pass through this, and to make something that is both interesting for us to do, because we really believe we can help people along the way, not to stumble upon the same problems that we had while doing this, and also pushing it to the max when it comes to the proficiency of our instructors, their backgrounds, their formal certifications and qualifications in the field, but also I would say we don't have any vanilla, so to say, safety guys in the team. So all the teams, team members of the instructor teams are in, I would say, triple profiles. So we're working on actual automotive projects in companies. That's the first one. The second one, we are computer engineers. So software people and hardware people. So coming from the field that are actually used today in the automotive, and we are also safety experts with even with degrees in safety and certifications with the safety. So this profile of the team is something that I would say is one of the best traits of this program. Speaking of the program itself, there is also a specific way how we teach. This experience, us talking about something, is something that is happening in a flipped way in actual courses. How does it work? So if we have an experience within a course, there is what we call a discovery week. In this week, one course a day looks like this. So you have approximately 1.5 hours. These are 2 class hours of lessons that are live. It can be online, it can be on-site, depending on the agreement. These programs that are open, so to say, are all online, so you can join from any place in the world. But during the course day, you can expect about 2.5 hours of effective work during the course day. How does it work? So usually over coffee in the morning, you do what we call async preparation. It's completely streamlined on our platform, on our learning platform. So you have a prescribed video lesson to watch for that day. It's up to 40 minutes. Usually it's half an hour. It's a digest version of the lecture. It's not crammed with information. It's usually just talk that you can enjoy while drinking coffee. And of course, you can look through the canvas a bit, see are there any interesting materials, etc. It will not take you more than 40 minutes. Usually we spend this time in the morning while we are at home, either going through news or watching some gossip things, or, you know, drinking coffee, chatting with our friends. We can spend this in watching this async material. And basically all ex cathedra style of teaching is converted to very interesting formatted videos and digested into this area, and you can use these videos forever. That's important. Together with the videos, you get the lecture notes. This is a document, usually 2-page document. What is actually the notes as if those were written by yourself. So you don't even need to take notes while watching this. So by having these lecture notes, you can quickly recap what you watched, and then you come to the live session that is as efficient as it might be. So this live session happens immediately after work. Usually it overlaps a bit with the work time. So if you, let's say, are paid to, let's say, go to this program from a company, the best model is to, let's say, start at 3 or 4 p.m. Usually these are times when this live session starts. So you don't actually feel like you are spending extra time. You're actually working on your project from, let's say, 9 until 3 in your company, and then at 3 to 4:30 you are in the live session. Live sessions are very much hands-on oriented. There's just a small introduction and quick Q&A, but then immediately we go to hands-on group work, and after that we present and discuss and close the topic. So the learning effectively happens in these live sessions. So these are not ex cathedra, these are very much practical and very much exercise driven. And then the last thing that we need you to do to really close the topic is before you go to bed, you have a quiz. It's 10 questions usually, yes or no questions. You go through those and you are done for the day. If you have something to submit, this would mean just to submit it to Canvas. Usually people do that during the session, not even spending time afterwards. So this is, in our view, the most efficient learning format, and it's very much different than all other formats of courses that you might come across. If you take a course on ISO 26262 anywhere, you would be given a set of bootcamp style presentations. It would be crammed in 3 days. You would get 300 slides of materials, and the only outcome of this kind of teaching would be to get the slides and go home. So you would learn effectively just a little, maybe just a few terms here and there. This approach would really give you the opportunity to comprehend the material, and this is our paramount goal. So to make you feel empowered when you leave the course, to actually know something and not just to be handed out material, okay? So this is very, very important. This style of teaching would happen 3 to 4 days per week. So let's say Monday, Wednesday, Friday, or Monday, Tuesday, Thursday, Friday, something like this. So you would have a day off during this discovery week. So not every week is going to be full, and also weekend is going to be empty in this case.
Yeah. Something, if I may. Each of these course days are atomic units or modules. So in each of these days, we are addressing separate, rounded, and atomic module on a specific topic. So it's not diluted, it's not overreaching, but rather like a digestible amount of content and digestible amount of exercise, which allows you to combine both this async preparation where you will read and learn about things, and then these live sessions where we will assist you to actually put in practice through realistic examples and to actually create some output that we will further evaluate and give you feedback. So this gives you a nice rounded way through 3 steps to have atomic ways to absorb the knowledge and to really carry it with you, not just take the slides and go to the next course.
Right. So this is exactly how this is being done. There is another type of week that you might encounter in the course. It's called the productivity week. It has a little bit different format. It's about you working on your project and therefore applying what you have learned. Okay, you worked on your own during those sessions, small sessions, but now you need to assemble several topics together and to craft your own project assignment. And based on the result of the project assignments, you can get also the grading, and you will feel in control there, and you will feel like comprehending and connecting things. And it's very, very important to have those projects. What we do in this productivity week, during the first day, usually you have a project intro. It's again over the coffee on Monday morning. You watch a short digest video, and then you have probably that same day, you have the project setup live session. You get the reveal of the project. You have a project planning session with instructors. Then all the Q&As happen and the projects are kicked off in teams usually. And this is the only live session that is substantially, let's say, directed towards helping you in the project. The rest is mostly self-paced, meaning asynchronous. Here are the things that usually happen in teams. So after this kickoff meeting, this setup, you have your team meeting to discuss the work, to address common things, and to split the work. And then each of the team members usually needs to spend some individual time to sort out their own respective parts. It will be, let's say, the most intensive part. Probably you would need 2 sessions of 2 hours or however you want to pace it. The good thing about this whole approach is to give you the chance to plan your time more easily. So you would not be locked in for hours in a course. So you would be obliged to have, let's say, 15 meetings with instructors that last for an hour and a half. The rest is up to you when you're going to do this asynchronous parts and when you're going to do your chores for the course, okay? There will be interception with a live consultancy session of 45 minutes somewhere midweek. And before submission, probably you would need to have another team meeting to integrate all the work products, to further discuss, to prepare the presentation collateral, and to do submission in Canvas. And also, finally, we get together again live in the session where all the teams present their projects, about 90 minutes, hour and a half again, at the end of the week. So this is how the productivity week usually works. Of course, based on the actual planning of the course, it might slide one day into the next week, etc. This is just an idea how it works in principle. Different courses have a little bit altered ways, but in general, the principles are like this. And how the course now works in total, maybe it's important to circle it out in this way. The courses in functional safety program are what we call 3-unit courses. It means that you have 30 classes of live teaching, and you can expect 30 more as asynchronous work, meaning finalizing projects and watching digest videos, comprehending the material on your own. But it would be programmed, so we would not leave you out in the dry just to do whatever you want. You, of course, can be motivated to do something extra, but these 30 class hours of asynchronous work are going to be needed and going to be programmed within the course experience. So in this particular sense, we have, let's say, a course that has one discovery week, then the productivity week, then discovery week, then the productivity week, and in the end, we have a standard exam. So the course would last anywhere from 4 to 5 weeks, 5 weeks max, of teaching one material, and now you have the idea approximately on what is the effort you need to take for a course. So it's what you see here, we call the intensive mode. So it is possible to stretch out these courses if we are ordering them in custom fashion. So not in this full round, but in the custom fashion, when you order the course, you can say, okay, I want them to last 7 weeks in total, so that the material gets stretched out more. Maybe people would like to feel more relaxed, or 8 weeks or 10 weeks. But it cannot go shorter than 4 to 5 weeks in total for a course of 3 units. The same goes for the courses of 2 units. It is 20 plus 20 classes, usually 2 discovery weeks and 1 productivity week, and then the exam. So 3 to 4 weeks is the load for these courses. And it is important to say that you can work in your job and take these courses. So that's very important. But again, you need to be ready to spend in one calendar month maybe additional 30 or 40 classes of learning, 30 or 40 hours, let's say, of learning. And if the employer gives you some relief time from the work, let's say if your workday is 6 hours instead of 8, then it's pretty easy. If your workday is 8 hours, it can be a little bit more cumbersome, but it's still doable. And I think it's well worth the effort. Okay, so before we go into the Q&A, Bogdan, maybe you can tell us a bit more about what is on disposal for our course participants, maybe to go through.
Sure. So all of the materials that we have prepared are original ones. They are curated and they are according to certain standardization that we expect from all the instructors within NIT Academy and NIT Institute, and also according to US San Diego Extended Studies normatives. So all the materials are available through Canvas, which is a state-of-the-art platform for, let's say, hybrid learning. All the materials are well organized. So as Milan has already mentioned, you will get a video material that you can access anytime during the course execution time, but also sometime afterwards. Then you will have a summary or a lecture notes in a written form that you can consult later on when learning, or if you want just a quick refreshment of your memory, and you can use it also during the live session. And then finally, to come prepared for the live session, you can test your knowledge and your understanding through some self-assessment quizzes. With all these three, you can have a nice rounded story for this atomic unit. And then in order to come prepared for the live session, you will have a description of the exercise, what things you might prepare but not do, because we want to do together in the live session and in smaller groups. So this so all of this is available and organized in these atomic units that are called modules. Video materials, all of them are in English. All of them have subtitles, and the idea is not just to go through slide deck and just bore you with the content. We really prepared condensed the selected topics that you can appreciate while hearing about these new things. And then if we move to a practical arena, everything that we are teaching can be done on state-of-the-art hybrid learning virtual lab, meaning that you just need a PC with a stable internet connection, with usually either a Zoom installed on your PC, and will provide you a remote desktop tool, which will allow you to jump in directly to our virtual lab. In this lab, you will already have a dedicated seat, a dedicated PC that you can use, which is already pre-installed, pre-configured with all the necessary tools that you can use. So for these functional safety trainings, there are some specific tools for analysis and for especially for software coding. But if we move to the other other part of this hands-on courses on programming, on network communication, etc., then you will have tools that otherwise would take you up to 50,000 euros to purchase and to assign. And through this virtual lab, you will have direct access to this kind of state-of-the-art materials. And finally, Milan spearheaded the way to provide you also original textbooks, and you have this one of the first one of these books on the topics entitled Systems, Functions, and Safety, and we hope to have more of these textbooks for those who are keen to really appreciate all the materials in depth and in a systematic way.
Okay, and last but not the least, let's speak a bit about scheduling. So how these things work. So if you like what you heard and you would like to explore this route, there are two options. So one option is to enroll into the existing cohorts that run starting from this fall, and you simply be assigned a seat in the course. The course groups are not big. So usually it's around 16 people, up to 20, but not 21 and not 22. So it would be 20 as a max number. Usually it's less than that. It tends to be very efficient, working in, let's say, 4 or 5 smaller groups in different breakout sessions, etc. So it starts to be, it's very efficient. And the impression is that you are not enrolled in a massive online course. You're enrolled. The impression is that you're enrolled in a live teaching experience. So as if you are the part of the class with your instructors. September the 1st is the start time for the Systems, Functions, and Safety course. The enrollment is open even now. So it usually closes 2 weeks before the start of the course. So it is that way for each of the courses. Who wants to go to the complete track? It is possible to finalize the certificate one course at a time, one after another. We have 1 week off between 2 courses, and to get the full round of know-how by beginning of March 2024, if you are that ambitious. If not, you can just handpick some of the courses that you find interesting based on these dates. So it starts this fall and ends with this particular round somewhere Q1 2024. However, the other approach is to contact us directly as a company, even as individuals, but mostly as a companies in B2B fashion, and we can schedule custom cohorts completely and even custom programs for you, meaning that you can tell us your story, where you are at, where you want to go, and we can say, okay, do this, and that, and we can prescribe training paths also for you. It can be more than training. It can even go a bit into the consultancy area around these same topics, okay? All other courses that we mentioned, this list is not exhaustive here. You heard more during this presentation. So all other trainings and programs you can always find in the NIT Institute website, academy.nitinstitute.com, or schedule updates. Also the UCSD pages, you can look through the UCSD extension. There's tons of different course material that mostly happen live, and you can also enjoy and appreciate from the UCSD Extended Studies Department. Okay, so again, the opportunity for a discount is here. And while we are looking at this and keeping this up, maybe we can open the round of questions if we have some questions from the audience. Okay, so I can maybe tackle this one. Bogdan, courses can be transferred as credits at some MSc study programs at universities. Is it possible to study MSc in an online way? Which kind of MSc program is available for that? Is it going to be with the thesis or non-thesis? Thank you. Okay, so okay, we had one question before. Nenad will pardon us. Maybe Bogdan can answer that one. Currently, we have a program equivalence with the Master Studies of the University of Novi Sad in Serbia, Faculty of Technical Sciences. There is an automotive major in this faculty that would accept for I think all the courses from the FSFA certificate as equivalent to master courses, but you still need to work out the thesis. So you can work out the thesis with on some of the functional safety topics as well as a part of an automotive software. There are teachers at the Faculty of Technical Sciences that would be happy to provide you mentorship and guidance, I'm sure, for these topics that are very relevant in the automotive world, but though it would not be handled by the UCSD. Also, the UCSD and those institutions are not affiliated, meaning that it is up to professors to grant you credits or not grant you credits. We had experience last year and the year before that it happened for several colleagues, and it is possible. It is also possible to do with the University of California for some programs, but you should probably write directly to Ljubica Plavšić. I see her here, maybe directly or through the course pages of the Functional Safety Fundamentals Certificate to find out which other possibilities of equivalence exist. So currently, the only one that we really have here locally in Europe is with the Faculty of Technical Sciences in Novi Sad, Serbia. However, I know that the UCSD also has a lot of equivalence options with the UCSD programs of undergraduate studies as well, maybe even masters for the safety disciplines. So yeah, this is worth exploring. Ljubica, maybe you can share a bit with us. I see you raised the hand.
Yes, hi. Can you hear me? Yes, you can hear me. Hello, good morning here in the US. I think it's evening over there. Just quickly to add to this, our courses, in many courses in our institution at Extended Studies can be transferred to other institutions. However, we cannot guarantee you this. You have to reach out to the receiving institution and check with them if they are willing to accept our courses and they're willing to, use the credit towards their program. But it's something that is done, and in many other areas we do that, and many institutions do receive our, credits. So it's a matter of investigating and asking. But yes, otherwise it is possible.
Thanks. So I think this clarified a lot what we were wanting to say. We tested it out. This Functional Safety Fundamentals for Automotive is a new program in this format. However, now we have a third generation, and the previous two generations did do this equivalence. So it's well stabilized, I would say, by now. So it's good to know. But perhaps there will be more questions asked for other institutions, and we could get more from the ground information whether something can be done or not. But it's up to teachers.
If you have any questions regarding that, especially here in the US, feel free to reach out to me, and I can guide you through that. And if many times what institutions are asking for are just the syllabus to check the topics that have been covered, and sometimes that's enough. So I'll put my email if anybody has a question.
Mm-hmm. Great stuff. Bogdan, would you like to attend to Nenad's maybe question?
I guess we already did partially, because this is why I made a stop when we were discussing about the the course format and contents. But yeah, just to recap again, definitely all the materials that we provide for the individual modules and for projects and for the courses as a whole are inspired and motivated by and relevant from the current and past automotive safety projects. So because, as you mentioned, all of us have previous automotive and functional safety experience in the industry.
Mm-hmm. Okay, we have questions from Boyan. Are there any feedbacks, reviews from former attendees of mentioned courses that can be provided? Of course, there's plenty. Maybe it's best not to get those from us. Maybe we could put you in contact with people that got these degrees already. My colleague Christian is on the line, and he would be happy if, Boyan, if you leave your email, to send you a few contacts. For people that went through the program already, so that you can reach out to them and pull them directly, of course. So it's
of the links from LinkedIn that you can see, it's from our previous generations. So you can take upon this link, and then I guess by using the hashtags you can find more. But I guess Christian can follow up with more.
Yeah. Okay, so what is the general way of enrollment? So feel free to write us directly. So you can do it, of course, through the websites of the UCSD Extended Studies Department or through NIT Academy. But we would really love to understand who the people are who are interested into the program, so that we can really talk to you before and provide you a customized experience. Maybe we will tell you, don't do this. So it's also possible if your, let's say, background is not sufficient. The good thing about functional safety program is that actually any engineering background can enroll, so that's for sure. If you are a non-engineer, it can be a bit tricky. So we need to give you some kind of aptitude test, because it can be a little bit harder if you didn't have these fundamental math classes, and let's say if you don't understand block diagrams and formula and those kind of things, graphs and whatever. So you need to have this fundamental engineering background, like a BSc in any kind of engineering where you did have some mathematical courses, like some algebra, statistics, and stuff like that. But other than that, we don't require you to be a programmer or to be a software engineer or to be a hardware engineer. It's beneficial if you're working in software or hardware, because you would get the most out of this course, being that the team that teaches is really well versed into these areas, and you could really reap the maximum from it. But even if you are not from these backgrounds, you could go very well through at least the functional safety fundamentals for automotive, but also through some other courses in the round. Okay. If we don't have anything else to add, Bogdan, do you have anything else maybe that is worth mentioning at this point?
No, I think we were quite focused and and on point in our deliveries.
Okay, so we are here for you. So if you want any additional information, feel free to reach out to us. And I would like to thank everyone for attending this session. We are right on time, and see you hopefully in the coming weeks. Goodbye, everyone.
Bye-bye.
Bye.
Thank you, Milane. This was very, very informative. I really appreciate it. So
thank you for joining as well this early.
Absolutely, no problem.
Thank you.
We'll be in touch.
Yeah.